All right, we're going to be discussing feedback loops. And in this case, a simple example for you is something you've typically done, which is you've emailed me and I replied back. We call that initial email and reply back by me, a feedback loop. There's two possibilities to that reply back. The first one is a positive feedback loop where Mrs. Noble will email you back with a confusing reply, causing you to have more questions, so you email me a couple more times. See, now notice the emails amplify. There's more emails coming as a result of the first email, after the first email. A negative feedback loop is called a stabilize event. And in a stabilize event, what happens is you email me, I email you back with a reply that is fully to clarify your question, so you're happy and you stop emailing. My reply has stabilized because it stopped the emails. Whereas the other one, the positive feedback loop, is causing an email chain. And so that's an amplified situation. The hard part is the relationships between the events. And so what I need to clarify is that the key to knowing what the relationship is, whether it's positive or negative, will depend on the effect between the cause and effect events. So the words that you're looking for in the effect is, for it to be positive, is these words like more, increase, grow, release, elevate, cooler, and produce. Negative relationships is where you're seeing less, decrease, decay, inhibit, and escalate, or de-escalate, warmer and reduce, etc. So here we have an example of the human population. Again, our focus is seeing how the human population is affected by this loop that we see here. It starts with parents giving birth to children. That's a positive because you're having more kids, a higher amount of human population. In other words, an increase. And then those children are going to grow up and become parents. So now this is an increase here as well. So there's a positive relationship here. Overall, this feedback loop is considered an amplification for human population because as parents have children, children become parents and give birth to more children. This loop is an ever-growing or amplification of the human population. Let's look at some climate feedback loops. Here we have global temperatures increasing, and so wildfires is what we're focused on. These global temperatures increasing is going to cause these drought conditions. So that's negative because drought conditions are lessening it's a decrease, a reduction in conditions. And so here you're actually causing wildfires. And those wildfires are going to increase the CO2 because as things burn, you release more CO2 in the atmosphere from the burning of the dry fuel. That causes a further increase, and notice the outcome is positive, and so this is a positive outcome. Now let's go this way. This way, the drought conditions and the wildfire that cause these wildfires are going to cause more ash blown away by the wind settling onto land. And so the more ash, the result, which is the outcome, is going to lead to a positive relationship. As more ash is deposited on those land, it's going to cause more reflection or less reflection and more absorption by that land, increasing the energy that's going into Earth. And so more of that energy from the visible light will then entering Earth will further increase. And so that's increase. And then that will further increase the global temperatures in the end. So overall, wildfires, as we look at the events and the cause and effect of each of the parts of the events, you're seeing wildfires are further increasing global temperatures. So this is a positive feedback loop. because it's amplifying the situation, the starting situation. Now, electric cars are going to, if you look, increase in global temperatures is going to cause greater production of electric cars. And that will then lessen the amount of CO2. So here we see a positive effect there, and then a negative effect because there's less CO2 as a result of an increase in electric cars. Now, the less decrease in CO2 is going to decrease global temperatures. So this is actually going to oppose this starting point, and so you're seeing a negative relationship. And overall, it looks like electric cars are going to stabilize the starting point by decreasing the temperatures, and thus this is a negative feedback loop. In the ice melt, the global temperatures are increasing. This is melting more land ice, so this is a negative impact. And then that will cause more CO2 because underneath that land is permafrost that's thawing out and releasing more CO2. And so that more is a positive effect. Increasing, so that's positive. And now let's move down below here where we're seeing land ice melt increasing. So this is a positive relationship, thus causing more black dirty ice with low albedo absorbing visible light and reflecting as infrared. And then, of course, that increases the global temperatures. This ice melting is further increasing global temperatures, so we call that an amplification effect, which is a positive feedback loop. Clouds. Starting temperature, or your start is global temperatures increase, more ice or more water vapor will form clouds, more clouds, which then, so that's a positive relationship, decrease. And then, so now the clouds are going to reflect a lot of that visible light and decrease the energy that would be going to Earth's systems. And so this is a decrease, which leads to a negative effect. That decrease will then actually lessen the temperatures. And so you're seeing a negative effect. And so clouds actually are stabilizing the system. And so this is a negative feedback loop. Now, if you look at these loops, these are more complex, but run through it. Again, looking for keywords like grow means more, so you're seeing a positive. And so as large herbivores eliminate large plants in an area, more grass will grow. And as more grass grows, more herbivores will have plenty of food to grow, and so that will be positive, creating a positive relationship for the herbivore population to grow. Now it can go two routes. Both routes will be positive. You're going to have more herbivore waste, and then that herbivore waste will fertilize and produce more grass. And so ultimately these are all positive effects on this side. Well, on this side, you're seeing more herbivores population growing. That causes more herbivores to move in these new areas, and thus this will decrease the land or the large plant areas for the herbivores. And so this is a negative effect. And so ultimately, you're seeing that large herbivores are going to cause and support more grass growing and grass growth through these landscapes. And so that will eliminate a lot of our large plant areas or large plants in an area. And so that's a positive feedback loop. Forest fires are ultimately also going to cause more global increase in temperature. So that is a positive amplification effect. And so let's see how that route goes. Of course, it starts with global temperatures increasing. Now there's a dry out occurring, so there's a decrease in plants as a result of plants dying from that increase in temperature. So it's negative. That plant dry out is going to cause more fuel for the fire, so more forest fires are going to occur, so that's positive. And that leads to less plant life due to forest fires. And so here's your negative relationship. Less plants lead to more stored carbon that's released as carbon dioxide. So you're actually seeing carbon release out into the atmosphere positively here, and that increases temperature positively as well. If you have less plant life due to forest fires, that's going to lead to less CO2 captured because the plants are the ones that do photosynthetic processes that capture CO2. But with them dying, you're going to see less CO2 captured. And so there's the negative effect as a result of the less plant life. And of course, that produces more CO2 because there's less captured by the plants. And so ultimately increasing the global temperatures. Over here, the negative feedback loop here, both of these are going to stabilize the system. So ultimately, you're going to see some positives and some negatives to counteract that. Growth as plants and photosynthetic organisms evolve, plants and photosynthetic organism populations start to grow. So that's positive. That decreases CO2 in the atmosphere because they're the ones that uses up that CO2, and thus decreasing global temperatures in the end. And that slows weathering, and that slower weathering is going to increase the amount of CO2, so that's a positive effect. Increasing global temperatures positively as well, causing faster weathering if you want to go that direction, or ultimately that would cause more plants to evolve overall. There's also this route where you're seeing growth as well, and so that's positive as well. So ultimately, this is a negative feedback loop because ultimately you're seeing in one direction, you're seeing a decrease in CO2, thus temperatures going down, and thus slowing chemical weathering and lessening the plant growth and organisms that are out there. But also you can see that you can see also the pathway where there's going to be more plants, faster weathering, which leads to different, it can reroute over here, but then it also can increase the atmospheric CO2 and increase global climate temperatures and ultimately increase the number of photosynthetic and plant organisms that are in that evolve over time. Now let's look at negative feedback loop with clouds and climate. Here you see, again, lots of some negatives over here and positives over here. So you're going to probably see what is called a stabilization occurring. Increase in temperatures increases evaporation of water, and so that's positive. More clouds, positive. More albedo, so that's positive. Now the more albedo actually lessens the light that reaches Earth, and so that's a negative effect, and that decreases temperature. Again, the result is it's decreasing, so it's a negative effect. Decreasing evaporation, which is negative, and fewer clouds coming out of that decrease in evaporation, leading to albedo, the albedo effect decreasing. And with albedo effect decreasing, you're seeing more light reach Earth because, again, those clouds with fewer of them are going to now hit Earth and heat up the planet even further. So you're seeing an increase here. So ultimately, you're seeing a stabilization for clouds. Clouds actually will, more of them will decrease temperatures, but also fewer clouds in this situation where temperatures decrease will lead to more light hitting Earth and increasing temperature. So notice how you see global temperatures increasing and decreasing in this loop. It can do both. If you see something like this, oftentimes you will see the counteracting that's occurring to stabilize the system. I hope that helps.